Hello friends, welcome back to our channel. So today we will discuss about binary codes, the importance of binary codes and what are the different types of binary codes, right? Yes. So we know that any digital system will be understanding the binary language, that is either zeros or one. So any digital system, so example you can consider as a computer, so which understands binary language, which is either zeros or ones, right? So here the binary code, what is meant by a binary code? So binary code is a method to represent, this is important, to represent, okay, to represent information in binary format. So here information means any kind of information we'll be getting. So we'll be using letters, numbers, and sometimes we'll be using symbols. Any kind of data we call them as a information. In order to represent that information, we required one method that is called as a binary code. So here, see, digital system we are saying, why only binary format means, if you consider the digital circuit, so circuit will be having the voltages, okay, so digital circuit can be operated with only low or high voltage levels, only high and low voltage levels. Usually 0 is a low voltage, 1 is a high voltage. So in the digital systems, we'll be using these digital circuits. So digital circuit, the voltage level, digital circuits will be operated with only the voltage levels, which is low voltage and high voltage. And see, the binary code, this is the method to represent any kind of information. So if you want to write any programming instruction, so that should be in a binary format. That means either zeros or ones. So here we can say 0 as low, 1 as high, or 0 as a false, 1 as true, or 0 as on, 1 as off. So binary means only two results. Now coming to this binary code, how many types of binary codes are there? Okay, different types of binary codes in order to represent the information. Types of binary code. So first one is a weighted binary code. Weighted means the name itself indicates. So every digit, okay, every decimal will be represented with some 4-digit binary value. Okay, so every binary will be having some weightage. Okay, every binary value have some weightage. Okay, so here every decimal will be representing with 4-bit code. So what is this 4-bit code? 4-bit code means it is a 8421 code. 8421. Okay. So example, so if you want to convert this decimal as some 9, this should be represented with 4-bit code. That means 1 0 0 1. So this should be multiplied. See, every bit will be multiplied with some weight. So 1 is multiplied with 1, 0 is multiplied with 2, 0 is multiplied with 4, 1 is multiplied with 8. So this kind of thing is called as a weighted binary code, and this process is called BCD, binary coded decimal. This is not a binary code, this is called as binary coded decimal. So here every decimal digit will be having some, should be represented with a 4-bit code. For example, take some 43. So how 43 should be represented? This particular decimal will be represented in a binary, and this decimal will be represented with a binary. So 3 can be having, so 0 0 1 1 and 4 0 1 0 0. So this is the weighted of 4, and this is a weighted code of 3. So this is the BCD code of 43. BCD code of 43. So BCD code is different from a binary value. Okay. So here every digit of a number will be represented with a 4-bit code. So this is a weighted. That means every bit will be having some weightage. So here the weightage is 8421. So this is the weights for every digit. Okay. Next. So the first type of binary code is weighted binary code. And the second category is a non-weighted. Non-weighted binary code. So here non-weighted means there will be no weight. No weight will be given. No weight will be taken. Okay. So here the example for this non-weight code is gray code. Gray code representation. Gray code representation. Gray code representation means every consecutive words will be having only 1-bit difference. Every consecutive numbers will be having only 1-bit difference. For example, if 0 is represented with 0 0 0 and 1 will be represented as 0 0 1 and 2 will be represented as 0 1 1 and 3 will be represented as 1 0 0. So how we will be getting all these things means consider this one. Consider this part. Okay, so we need to consider gray code of 2. Okay, gray code of 2. This is a gray code. So how we can find out the gray code of any number? So first what we have to do? So we need to take the decimal, binary. So binary for this 2 is 0 0 1 0. Okay, 0 0 1 0. Let it be binary 1, binary 2, binary 3, binary 4, or simply we can take it as we need to consider from right to left, B0, B1, B2, B3, and here G0, G3, G2, G1, G0. So always consider the MSB bit with this particular thing, right? So B3, that means 0 will be here. Next, how to get the G2? G2 will be XOR operation of B3 and B2. So which is XOR operation between 0 and 0, 0. G3, G1. G1 will be XOR operation of B2 and B1. What is a B2 and B1? It's a 1. And G0, again XOR operation of B1 and B0, which will be 1 and 0, 1. So you can write it here 0 0 1 1. So This is the gray code of this particular 2. Gray code of particular 2, right? So this is how we need to calculate the gray code for any decimal value. So the first MSB bit will be same, and from the next bit onwards we need to use some XOR operation. So in order to get this G2 gray code 2, so we need to XOR between B3 and B2, binary digit third one and second binary digit. So like that we need to calculate the gray code, and this is an example for non-weighted binary code. Here there is no weight. Okay, here there is no weight, but every consecutive numbers will be differ with only one bit. That's the only difference. Next, this is the second category of binary code, and the next one, alphanumeric code. Alphanumeric code. So this particular code will be used to represent letters, that means alphabets, numbers, symbols, etc. Okay, so the example for this alphanumeric code is ASCII. ASCII value. ASCII means American Standard Code for Information Interchange. So there will be a unique decimal value for every information, right? So I'll write here. So ASCII. So every information will be having some unique value, right? For example, capital A, the unique value, the ASCII value of capital A is 65, capital B 66. Similarly, small a 97, small b 98, and so on. So like that, for numbers there will be different values, and for symbols there will be different values. Okay, so maximum to represent these things we require around 7 or 8 bits code in order to represent this particular decimal value. This is a decimal value, and we require some 7 to 8 bits to represent the we require some 8 bits to represent this particular decimal to binary value. So this is the third one, alphanumeric code. Okay, and the next one is a error detecting code. Error detecting code. So here the name itself indicates during the transmission of bits from one device to another device, if there is any error occurred, so in order to detect that error, this particular code will be used. For example, see, used for error detection, not a correction. Okay, error detection. It will only detect, right? And example for this one is even parity check. So we simply call it as a parity check. Okay, there will be even parity and odd parity. So let us take a even parity. For example, A sends a message like 1 0 0 1 0 and also 1. Okay, so this message has been sent to device B. So the message received was, see, what happens here, if before sending the message to receiver B, so it was using the even parity. Even parity means the data should contain even number of ones. How many number of ones are there? Here 1 2 3, but here it is having only 3 ones, which is a odd. So what happened? To maintain this even, add parity bit. So this becomes, after adding this parity, 1 0 0 1 0 1 1. So now how many ones are there? This contains even number of ones. So this will be sent to receiver B. So if receiver B receives the same information, so B will check the parity. Okay, B will check the parity. So it's also having the even parity. So obviously that means there is no error during the transmission. Okay, so this is like, similarly there is a one more parity called odd parity. So here it will check for odd number of ones instead of even number of ones. It will check for the odd number of ones. So basically this one is a for error detection, not error correction, error detection. Okay, so this is another type of binary code which we are using, right? So four types of binary codes we have used. That's a weighted code, weighted binary code, non-weighted binary code, alphanumeric code, as well as a error detection code, right? So hope you got a clarity on how, what is a binary code. So where we are using this binary codes applications, what kind of applications? Okay, simple application, computer. So while we are using the computer, or while we are using the keyboard by pressing the keys, so there we are using this binary codes. So if you are using the keyboard to enter the characters, that will be storing in terms of ASCII values. The ASCII values will be used. Okay, so this is the complete importance of binary code and the types of binary codes, right? So I'll stop here and hope you enjoyed the session. If you really enjoyed the session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.